Our traditional approach to surveying replacement pipes and structural elements has been to wait for a few defects to kind of build up, and then we've been sending a onshore surveyor offshore for a week or so to go and do a survey on a few different bits of pipe and structural elements that need replacing.
The traditional method was taking a long time. Typically it would take about a month to find a space in the plan for the surveyor to get offshore, and then we'd have to build up maybe 5 to 10 jobs for him, so he would have about a week's worth of work. This was taking a long time, and it was also the cost involved with having to mobilise a surveyor, and he was taking up a bed that could be used for sort of other more urgent work.
So over the last year or so, Step Change Engineering has pioneered and successfully demonstrated the use of the handheld scanners as part of an integrated workflow solution for repair orders and brownfield modifications. The workflow involves a 3-step process: data capture, 3D modelling and auto-generation of design deliverables. Data capture is provided by the infrared scanner, and that provides input into a powerful design application suite where most of the engineering and design work is done.
This is the scanner. It's a very simple piece of equipment to use. I've taught various people offshore how to use the piece of kit. It's just a tablet and with some software on it, and it's got a camera at the front there, which is an infrared camera. You switch it on and we hit the top right hand corner, which is start mapping. It's a very quick piece of equipment. A survey about 4 metres square. It's only going to take a couple of minutes. So I'll just stop the scan there. And that's very quickly a very, very good scan of the site. Once the scanning is complete, all we do is finish mapping, saves very quickly, and then we can then email the information back on shore for the office to use.
The next step is to bring the scan into a modelling environment. So we've got an empty 3D model, and that's the exact scan that we've done outside, and it's now in a modelling environment now. So we can start placing pieces of equipment and various other pieces of information in and around that.
We started discussing this technology and our workflow with Shell about a year ago. It was evident that Shell quickly realised the huge potential and the impact that this technology could have on its offshore facilities.
It's quite simple to use, so I think that helped a lot. Everyone was quite keen, and as soon as they knew how to use it, they were keen to show other staff how to use it, and then we have quite a large group of staff offshore trained up on its use. Now we can find a defect, we can scan almost straight away, we can send the scan onshore, it can then be processed into a fabrication drawing for the new piece of pipe or structural repair, and we can get that order placed on the same day, whereas previously this was taking up to 6 months or longer.
So currently we're using it or trialling it on some of our Brent facilities, and it's gone well so far. But we see a case for expanding the usage of the scanner more comprehensively on our Brent facilities, and also expanding it to other facilities in the North Sea and potentially elsewhere. So there's a few different applications, and we're looking at how we can make best use of this technology for the future of Shell.
The application of the technology has a huge benefit for all operators operating in the North Sea, especially in this current climate with the low oil price. We've realised savings of over 70% on cost, over 90% on schedule, and eliminating the need to send people offshore is again a major attraction for operators.